Greetings, this is a screencast recording of my 2014 DevLink presentation, What Writing Fiction Taught Me About Writing Software. A few details about me. My name is Nicholas Cloud. I am an architect and a project lead at Append2. My Twitter, GitHub, Goodreads, and website handles are all Nicholas Cloud, as you can see on this slide. My company's website is append2.com, and the avatar here is courtesy of my coworker Tony the Beast Hedrick, who thought it would be interesting to see what it would look like if I was featured in the show Archer. So I thank him for that wonderful avatar. This talk came about because I participated in a contest called NaNoWriMo, and I did this last year in November. And the goal of NaNoWriMo is for individuals or participants to begin on November 1st and to write a novel, a 50,000 word novel, by 11:59 p.m. on November 30th. So you have 30 days to complete a 50,000 word book. You can do a little bit of planning beforehand, but you can't do any writing beforehand. You have to start fresh on November 1st. It's a personal contest. There's no actual awards. There's no actual winners. It's just to see if you can actually do it. You know, it's a point of personal challenge. And so I decided to participate in this. I enjoy writing. I enjoy reading a lot of fiction. And it's been a bucket list of mine to kind of attempt to write a novel just for the challenge of it. The website is nanowrimo.org if you want to know more about this contest. But as I participated, I learned some things about writing as a creative process that I began to parallel to software development as a creative process. And this presentation kind of came out of that experience. So I created a spreadsheet when I first started, before November 1st, to basically project how many words I would have to actually write every day in order to reach the 50,000 word goal. So we have 30 days in the month, and out of those 30 days, I ended up having to write roughly 1,667 words per day. Some days it was a little bit more, some days it was a little bit less. There were 4.5 weekends during the month of November, which meant that, you know, I had extra time on weekends to write, whereas during the work week, you know, I would have to write early in the morning and late at night around my regular 8-hour workday. So weekends I could kind of front load if I needed to. 21 weekdays. There were 2 holidays, so Thanksgiving at the end of the month, which I would count as a loss because you're not getting anything done Thanksgiving Day, and my birthday, which was in the middle of the month, and I ended up actually writing on my birthday and said, no, I'm halfway through my story. I don't want anyone to ruin my pace, and so my family graciously allowed me to keep writing. So 1,667 words per day. If I spent roughly 3.3 hours per day writing, I would have to write 500 words per hour to make that happen, which doesn't sound like a whole lot. You know, we think, oh, I could definitely write 500 words per hour. But it's amazing how when you're engaged in the creative process, when you're actually trying to put together a story, how difficult it is to write 500 words per hour. If my book ended up being 20 chapters, this roughly meant that I would have 2,500 words per chapter. And if each chapter was broken up into 3 scenes, then that was about 833 words per scene. So I really tried to get a good idea of how the structure of my writing was gonna break down for me and how much effort I would have to put into things every day. So I quantized it this way. So there's a gentleman named Paul Graham, and he's been involved with a lot of startups. He runs an organization called Y Combinator. But he wrote an essay called Hackers and Painters, where he essentially did the same thing as I'm doing here, but he applied it to painting, which is a hobby that he has. And he talks about the creative process, and he says, because hackers are makers rather than scientists, the right place to look for metaphors is not in the sciences, but among other kinds of makers. What else can painting teach us about hacking? And here he's using hacking to mean software development. And so I'm asking the question, when I got done with NaNoWriMo, when I started thinking about the creative process, I started asking the question, what did writing fiction teach me about hacking or software development? Fiction in a nutshell. So fiction is a cross-section of three things. The characters in a story, the people that we're concerned with, the people who are actually doing things in the book, a plot, which is what they're doing and why they're doing it, some problem that they're trying to resolve, and the setting, which is when and where all of this stuff is taking place. So these three things are tied together by conflict. A reader wants to like your characters, worry about them through the whole story, and then feel relieved and satisfied with the ending. This is the typical formula for fiction. There's obviously different kinds of fiction. For example, in a tragedy, the reader wants to feel a strong sense of remorse and loss at the end, like Romeo and Juliet. That's the point of a tragedy. But for the most part, fiction is about characters in conflict in a specific place trying to solve some big problem. Okay, so with this in mind, I'm going to talk about all the different principles that I gleaned from the writing process as I was seeking to take this formula and put it into a 50,000 word book. So the first thing I learned is that you need to kill your darlings. And what this means is that a writer can get so involved in his story that he starts to have things or characters or places or ideas that he becomes emotionally attached to. And his story starts to revolve around these darlings instead of actually working to resolve the plot. Sometimes the things that initially drive a writer's story, they become obsolete as the story is being written. So a writer might realize that, oh, I had this great idea to start with, but my story is going in a completely different direction. Or this great character that I started with is not actually who the story is about. So if a writer is emotionally attached to a piece of their story, that piece actually probably is a good candidate for removal, because it means the writer can't be objective about it anymore. The writer can't actually evaluate the story as a whole and come to a conclusion about whether it's a good story or not, because they're too busy trying to make their darlings into something great. So in software, programmers can have the same problem. Our programs can start to revolve around our darlings instead of the problems that we need to solve. Sometimes the things that initially drive our programs, the initial ideas that we have, or the concepts that we're wanting to bring to life, they can become obsolete as our programs are being written. Sometimes a business need might change, or sometimes a project that we have a vested interest in, we find another library or another project that's already doing something that we want to do. And if we're emotionally attached to these things, if we're emotionally attached to our projects or specific pieces of code, maybe we have a particular way of doing something, and someone else comes in and says, this isn't the best way or a good way to accomplish this, and we feel emotionally attached to our code, so we tend to justify it no matter what. If we're emotionally attached to these things, they're probably good candidates for removal, because ultimately software is about solving problems. It's not about us being able to showcase our favorite things as developers. So that's the first thing I learned. Second thing I learned is that there are two types of writers. There are gardeners and architects. So this slide is going to cover discovery writers or gardeners, and my next slide will cover architects. So discovery writers, they have a nickname, we call them pantsers. And this comes from, they like to write by the seat of their pants. They don't do a lot of planning beforehand. They like to sit down at a computer or at a typewriter or whatever they're using and simply write kind of a stream of consciousness as stories come to them. So pantsers, they tend to have weak endings, but they tend to have really strong characters. So plot is what takes us to a satisfying ending. And a pantser is typically not concerned as much with a strong plot, how characters are going to solve conflicts, how they're going to work together, and how something is ultimately going to get resolved. They're more concerned with developing characters as kind of organic beings. In fact, they favor organic construction. They don't want any kind of preconceived ideas to pollute their view of their characters. A pantser, when they're writing, they have to do a lot of revision. And this kind of makes sense. They're, going along saying, well, I have a character at this point. What's going to happen in the next scene? I don't know. We'll just see how things develop. And eventually, you get to the point where you need to make your characters consistent. So if you arrive at a scene where you're like, it would be really great if this character was actually doing this, or actually had this personality or this attitude, but I've already cast them in previous chapters as being someone different. As a writer, you can change that as you go. The problem you run into, though, is that when a reader is reading your story, there's inconsistencies. So a pantser has to go back and do a lot of revision as they're writing to make their characters and plot and everything line up. Again, doing it by the seat of the pants, so things aren't going to necessarily flow, really well. Gardeners, they constantly entertain new ideas that can get in the way of finishing a story or can derail a story altogether. So they may be out, maybe they're enjoying a fall day in the park, and they see a person with a really uniquely looking person. Maybe they're walking a crazy dog or something like that, and they get inspired to introduce a crazy dog or a real unique person into their story, and that just changes the way that their characters interact, or changes the way that they anticipate their plot being laid out. The gardener tends to bring this stuff into their story often, and it disrupts the flow of the plot, disrupts the flow of characters. It may be a great idea, but again, they have to go back and revise to make everything consistent, to make everything flow really well. So in software, we also have gardeners or pantsers. This person tends to sacrifice maintainability for pleasing the customer. So when the customer comes to them and says, I need this change today, and the next day they come and say, I need this change tomorrow, the gardener is quick to accept this and say, yeah, absolutely, no problem. We can do it, even if it makes all the previous development, even if it throws it into an inconsistent state. The gardener tends to favor organic construction of software, so they're just throwing things in as needed. They have no real plan for the system. They're just going to patch things and tack on features and whatever as they go. And their code will tend to require a lot of refactoring because they're not concerned with the conceptual integrity of the system. They're simply adding features as it occurs to the decision makers. So they have to refactor to keep things consistent, to make things not break. If they don't refactor, pretty soon you get the big ball of mud type of system, which is impossible to maintain. These developers, they're constantly entertaining new technologies and tools that can actually prevent the system from launching. So I worked on a team where a decision maker could not actually decide on the tool chain or the technology stack that our team was going to use. We were constantly evaluating new technologies, and after months and months of this, we hadn't made any progress on actually creating what we set out to create. But we had a great smattering of technological demos that we had done over the course of several months that all did small little things, but ultimately had no value to the business. So this lead, this decision maker, was a gardener, and he let this kind of the new and the fancy and the shiny get in the way of actually making the system work. So on the opposite end of the spectrum, we have outliners or architects. In the writing world, the outliners, they like to plan ahead. They like to know what's going to go on in their story, how things are going to wrap up, what roles their characters are going to play. They have a vision from beginning to end, and they will plot this out before ever setting pen to paper. The outliners, they tend to create explosive plots that come together really well at the end. Again, they know how things are going to end. But their characters tend to be a little wooden because they're not really concerned with characters as ends in and of themselves. Characters are simply prop pieces for propelling a plot forward. So characters might seem a little generic, or they might seem like they're all the same person. Dialogue might sound like it's all the same person. But again, they're more concerned with getting the story done. And so the characters tend to take a little bit of a back seat. Outliners tend towards world builder's disease, which I'll talk about in the next slide. But briefly, world builder's disease is the the tendency of a writer to get stuck in all the details of their world at the expense of finishing the story. And they tend to rip through their first draft and completely ignore any revisions. So whereas the gardener goes back and has to do a lot of revisions as they're working, the outliner, since they know how the whole story is going to progress, they simply write it all down, and once they're done, they feel that sense of accomplishment. I've reached the end. You know, my plot is all banged out. My everything reached the conclusion that I wanted it to reach, and so they decide that they don't have to go back and fix anything. Any inconsistencies are inconsequential at that point because they finished. They completed what they set out to do. So in software, we also have architects, and they're called architects. And they have a tendency to overplan software systems. And they get into analysis paralysis. So they might have great documentation. They're a little bit old school. Maybe they have mountains of UML diagrams, data diagrams. They have an architecture all set out. Maybe it's a 7-layer architecture using all kinds of internal libraries or whatever, but they know how everything's going to work together. They spend a lot of time in meetings discussing the fine details of their system. They want to create extensive systems that are well documented and understood, but that end up being highly inflexible. They have to be inflexible because if you change part of the system, then the whole thing comes crashing down. Again, the architect knows from the beginning how it's going to end. So anything that's introduced as a variable in that, they tend to frown on. They tend to over-engineer, and they get lost in the details of their system. It's kind of like world builder's disease for software developers. And they tend towards the attitude of we have to get it right the first time. So they don't like kind of an iterative approach to development. They want to plan everything at the beginning, they want to execute it and write all the code, and then they want to deliver at the very end. So this is more like a waterfall approach to delivering a product. And in the software world, we see that this approach can oftentimes lead to systems that are brittle, that don't do what they need to do, because people are not very good at understanding all their needs up front. So the architect suffers from world builder's disease. And in writing, this is the tendency of a writer to get lost in the world being created at the expense of the plot and the character. If you think about a book like Lord of the Rings, J.R.R. Tolkien spent a lot of time developing his world. He created full languages for his world, languages that actually exist. You could actually learn how to speak Elfish, for example, and write Elfish. I mean, that's a serious level of detail for his world. So the world builder, they tend to get lost in these details to where they're more interested in developing the world and the details in them than they are actually writing. And so they never finish their book. Not that Tolkien ever did that. Maybe he did, maybe he didn't, but we have some great books that he did finish. But that's an example of what a world builder can get sucked into if they're not careful. They spend all their time planning, and so none of their time is left over for actual writing, and this can keep the story from ever being finished. So the architect, the developer can fall into this same kind of trap where they get lost in the scope of the program that's being created at the expense of actually implementing user stories and features that is useful to a business or to a paying client. They spend more time planning their software, and so that none is actually left over for development. And they'll keep their developers trapped in endless meetings, talking about all the great software they're going to build, never actually building it. And so, of course, this keeps the software from actually being finished. Another thing I learned, an important part of writing fiction, is that you want to have an idea of how your story is going to end. So a story is primarily about one ultimate conflict, which is what the plot's about. We're driving towards one resolution at the end, and the reader wants to know how the characters are going to resolve this one major point of tension. There's probably a lot of little conflicts along the way that serve to keep the reader engaged, but ultimately it's this one big conflict that we want to see what happens. Television shows kind of follow this same pattern. You want to know, for example, if Don Draper's secrets are really going to get exposed to the whole world at the end of Mad Men. Or you want to know if Voyager is ever going to get home to the Alpha Quadrant in Star Trek Voyager. Those are the overarching plots that we want to see resolved in a television show. Stories are the same way. So you want to have an idea of how your story is going to end. You want to know how the ultimate conflict ends kind of before you begin writing. Not to say that this won't actually change, but you need to have an idea of what the ultimate conflict is and how your characters are going to end up fixing the problem. In software, we want to know how our programs or our classes or our modules or whatever unit of development we're doing, we want to know what kind of problem is actually going to be solved at the end. We want to have an idea of the business or the technical need that's justifying our actual development. We want to know how these needs are going to be satisfied before we sit down and begin programming. So an idea of how we're going to solve a problem. This kind of fits well with the Unix philosophy that programs should do one thing and do it well. If we know the exact problem we're trying to solve, then we have an avenue by which we can start our investigations for potential implementation of a solution. If we have a vague idea of a problem, or if the customer doesn't know what they want, if they can't define their problem, then our software might as well do anything. It could do anything. And sometimes you end up with a client or a customer who is like this. They don't really know what problem they need solved. And sometimes the best thing you can do as a developer is define a few concrete problems for them and give them a choice of which concrete problem they want you to solve. And a lot of times the faster you can iterate on those concrete problems and get something in front of them that they can tangibly experiment with, a piece of software that they can see with their own eyes, that concretizes the problems that they actually have, and then they can tell you, oh, this is really what I need you to solve. And then you can begin as a software developer working on an actual solution. The next thing I learned is you want to write everything and then revise it. You want to, when you're writing fiction, you want to do your heavy editing and revising only after you know where the story is going to go or after you've finished your entire first draft. So this is kind of hard to do. You sit down, you write a couple of chapters, and you all of a sudden decide, actually, this character is a background character, the character that I thought was a main character is a background character, and this other person is a main character. And your story takes a radically different turn. This actually happened to me in NaNoWriMo. I was several chapters in, and I had a main character, and I just did not like this main character's personality. And I thought, well, what can I do to this main character to make them more interesting in the story? And I decided that I was going to introduce an element of anger. This character was going to be really angry about something. And it totally changed how this character had operated in the previous chapters, but it made it much more interesting for the duration of the book. So I put a note in my writing and said, hey, when you're done with the story, go back and fix this character in these previous chapters so that it's consistent. But wait until you're done. Wait until you're done with the story, because then you know how the character is going to play out through the entire story. And if you need to change him later on, you haven't wasted a whole bunch of time doing prior revisions that you will just have to revise again. So do the heavy editing and revising after the story is done, after your first draft is done. Sometimes you feel that you'll be struggling trying to write a particular passage, and you think, wow, this passage really sucks. I'm a really terrible writer. I don't know why I'm even doing this. When that happens, you need to put aside that writing and come back to it and revise it later. If you have a chapter that you just think is completely awful, just leave it like it is. Don't worry about doing heavy revisions. Just keep going with the story. Keep going with the plot and the characters. Sometimes you'll come back to that chapter and you'll realize that you were just having a bad day, that your writing didn't actually suck as much as you thought it did. It was pretty good, actually. And you have less revisions than you thought you would. Sometimes you'll come back to it and you'll decide to scrap it altogether because it's just not needed. And you were just having a little bit of a struggle as a writer trying to get the words out. But you want to put that aside. Don't waste time on something that you can go back and revise later. Don't perpetually revise. You want to do a couple of passes of your story and then call it finished. There will always be things you could tweak. There will always be things you can make better. But the idea is to get something to the point where it is good enough. I remember a Agile coach once told me, he said, the perfect is the enemy of the good enough. Everything is contextual. So when a reader sits down and reads your book, they're not expecting perfection. They're just expecting a really good story. And we all know that people make mistakes. And we all know that not everyone's writing is perfect. Even great authors will actually violate the rules of writing quite often. and they get away with it because their stories are compelling. The goal is to strive for good, not for perfect. So don't perpetually revise, just do a few passes, call it finished, and move on. You want to master revision early in your career as a writer. The temptation is to be more like the architect who, once you get to the end, you just put it on the shelf and move on to the next book. But if you need to go back and revise because it teaches you how to catch your own errors, how to catch the things that you're doing wrong to start with. And the more you do this, the less you will actually make those mistakes in the future because you'll know what your own habits are, and those habits begin to change. Make yourself revise even if you don't want to. It's a point of discipline, and you want to instill it in yourself early and make sure that you sit down and do the work to produce a quality piece of writing. So in software, if we think of revising as refactoring, we can kind of apply these principles the same way. Do heavy refactoring only if after you have established the structure and the flow of your program, and this is in greenfield development if you're starting a program from the ground up. For brownfield development, you want to refactor mercilessly, but you want to do it in small chunks. Introducing your unit tests, if you don't have your code already under test, to make sure that your refactoring, your small chunks of refactoring, aren't completely breaking your program. But in general, if you're starting from the beginning, from a greenfield project, refactor heavily after you've already solved your problem. Put aside code that sucks and refactor it later. If you have a function or a method or something, a module, and you're like, wow, this has too many lines of code, I could really probably do this a lot better, make a note, put it aside, and come back and revise it later. As long as it's working, as long as it's passing your tests, that's what really matters to solve the problem. But you want to go back and make sure that you clean it up and make it as clear and maintainable as you can. But don't waste time trying to do that up front. That's kind of a premature optimization. You want to master refactoring early in your career. And you want to make yourself refactor even if you don't want to. Just like revision in writing, this is a point of discipline, and it's a good practice to get into, to make yourself face your own mistakes and your own shortcomings, not to judge yourself and think badly of yourself, but simply to acknowledge that, nobody gets it right the first time, and that you can clean up your own messes later and produce something that's high quality. The next thing I learned was about how I write. When you're expressing things in prose, in fiction, and even in nonfiction, you want to use particular types of words. There are a lot of words you can choose from, but you want to use words, especially in fiction, that are concrete, that are immediate, and that are precise. So concrete words, they invoke a reader's sense. They have a tangible impact on how the reader is perceiving the story. For example, I could say, if I'm writing a book about the ancient world, I could say, well, the fighter did something. Or I could say, well, the soldier did something. Or I could say, the centurion did something. And as I move from left to right, you can see that I'm introducing a level of detail that in your mind, you start seeing a very concrete idea of what I'm talking about. Fighter is very generic. Could be any fighter. Could be a guy with a club. Could be a guy with a sword, whatever. Soldier, you get the idea of a more disciplined type of fighter. They probably are in a company. They probably march to war. When I say centurion, you know that I mean a specific type of Roman fighter, Roman soldier, with a specific type of funky mohawk helmet and a specific type of short sword and maybe a shield. And you have this real concrete idea of what I'm talking about. That's a concrete word. I want to say centurion. I don't want to say fighter or soldier. The same thing can be said if we have an example of either saying dog or mutt or mongrel. Dog is very generic. It could be any dog. It could be a Dalmatian, it could be a greyhound. A mutt, you kind of get the idea of a dog maybe living on the street. We don't know what breed it is. It's just, could be a mix. We say mongrel, the dog, you can probably see its rib cage, and it probably lives off the scraps in a very rundown little town. So you get a much more vivid picture when you choose concrete words. And we have a smattering of words to choose from to say the same types of things, and we want to give the reader a better mental image based on the words that we choose. So that's concrete. Immediate prose uses active words, not passive words. So instead of writing, John was swinging the large bat when he yelled at the pitcher, I should write, John swung the Louisville Slugger and mocked the pitcher. So instead of saying was swinging, which is a past tense version of a verb, I say swung. I eliminate one word, the helping verb was, and you get a much more vivid image of what John is actually doing. I'm using some concrete words here. Instead of saying bat, I'm saying Louisville Slugger. So you know this is a very large baseball bat. And instead of saying yelled at the pitcher, I'm saying he mocked the pitcher. And so we know that John is sneering a little bit, that we know what his attitude is towards the pitcher. They probably have some history together. So I'm using immediate prose to give you a very active idea of what John's doing, and I'm using concrete words to solidify it. When you write precise prose, you're going to write fewer words. And we saw that with both our concrete words and our immediate prose. We want to eliminate little words that are just fillers and actually use words that evoke more of the reader's imagination. So we end up using fewer of those words. In software development, we kind of have a similar formula that we can follow. If you use, for example, concrete variable, function, or object names, they can have a tangible impact on how people interpret your system. Naming things is very important. Instead of if someone jumps into your module that's maybe handling some sales processing or something, and they see the word item, well, what does item mean? What does a variable item mean? It doesn't convey any meaning about what is actually being represented by that variable. If we are working in a statically typed language, we can look up what the type is for item, and we can see what its properties, what its behavior are. But if we name it properly, if we name it maybe line item or order item or something like that, then we can infer some things about it. It probably has a price, and it probably has some other characteristics that you would expect to see on a bill of sale, or something like that. So naming variables, functions, objects in a system using concrete words is a very good way to express the intent of that system to someone who's reading your code. We want to write active and expressive code, not passive code. A maintainer should not have to figure out what you mean by your code. It should be self-explanatory. And we want to use fewer symbols in our code. So writing algorithms, writing things with higher level abstractions so that we don't have to fight through a bunch of symbols to interpret what is actually going on in a particular piece of code. So there's George Orwell has a theory of prose called the Orwellian theory of prose, and he said prose, or writing, is a clear window through which a story is seen. And what that means is that when you're reading a book, your eyes are actually reading words on a white page, but what you're seeing in your head is not those words. You're actually seeing a scene play out in front of your imagination. You're seeing the characters, you're seeing the setting, you're seeing the plot. So the prose, the writing on the page, should be transparent to the mind. The mind should be seeing the story. It shouldn't be seeing the words. A bad writer or a sloppy writer is going to cause the reader to struggle as they attempt to read the story. They're not going to be able to see the story because they're too busy tripping up on the prose. It doesn't convey the meaning clear enough, and so their mind can't make that shortcut, that bridge to the imagination. It has to concentrate on the words it's reading, and that interrupts the flow of the reader. So a little bit of a concrete example. How might some code look if we applied this principle? So I have a little bit of JavaScript code here, and we have some path here. Maybe this is a URL path. Maybe it's a file system path. And we're splitting that path on the slashes. So now we have these segments of the path, foo, bar, moo, and baz. And we're doing something with those segments. And if we sit here and look at the for loop, and we examine the if statement, eventually we come to the conclusion that what is happening in this algorithm is that we are looking at each parts of the path, and if a part begins with the letter B, which would be bar and baz, then we're adding that to an array called filtered parts. So when this code is done, filtered parts will have two elements, bar and baz. There's a lot of noise here though, there's a lot of symbols. So what if we What if we changed this and applied the concrete, immediate, and precise principles? And what if our prose looked like this? While check another. If the next part begins with B, then store that part. This is much more, in our mind, we know exactly what's happening here. We don't have to struggle through a number of symbols to see what's going on. We see immediately that this algorithm is actually iterating over a collection of parts, and for each next part, it's just checking to see if it begins with a B, and if it does, it stores that part. So this implementation here, and I won't spend a lot of time on what it does exactly, but the important part of the algorithm is down here. This while loop is what is actually happening. I break each of these steps, check another, next part, begins with, and store part, into small functions, and each function is only doing one thing, and it is exactly what the function says it's doing. We're just iterating over this collection, and we're examining each part. And if it begins with B, we're storing it. So even though this has more lines of code than the previous example, it actually has fewer words or symbols where it counts, and that's in the while loop. That's where the logic is actually happening, where the guts of the algorithm actually take place. And if someone had to come in and maintain this, they can see what's going on in this while loop, and it's a trivial task for them to look at, let's say, check another, and see that, well, I'm just returning a Boolean that says if the current value is less than the max value. And this function here is very uncomplicated. It uses few words as well. So this is a lot more clear. Immediate, concrete, and precise. Another thing I learned when I was writing fiction is about something called viewpoint. So when you're creating characters in your book, you're going to tell the story from somebody's perspective. Usually a main character, maybe a couple of main characters. And this perspective is called the viewpoint of the story. So there are two common viewpoints that are in fiction. The first is called third-person limited, and this is where the story is told kind of from a narrator talking about the main character in the third person. So we would say something like, Sally went down to the seashore to get seashells. So we're talking about Sally in the third person. We would use like the pronouns like she and her. But the story revolves around Sally. So it's third person. We call it limited because there's a rule that in writing that says that when you have a viewpoint character and you're telling the story through their eyes, you can know what that character's thinking and feeling. The narrator can express those things. But what the narrator cannot express is what all the other characters are thinking and feeling unless they reveal it to the viewpoint character through some kind of action. So there's no way that if we have Sally and we have John, and Sally's the viewpoint character, the only way Sally knows that John likes her is if John tells her in the story. We're seeing the world through Sally's eyes. Sally can't mind read. She doesn't have a view into John's soul, unless maybe that's part of our story. I don't know, but typically a person would not have those things. And so John is kind of a black box as a character. The viewpoint character, we can see what's going on inside their head. They're kind of who we're most interested in. Every other character is a black box in the story, and we can only know what they're thinking and feeling if they reveal it through actions or if they state it explicitly. First person limited is very similar in that we're constrained to the viewpoint character, but it's told through the narrator is the character. So they use the pronouns like I and me. I went down to the seashore to get seashells or whatever. So it's told from the first person perspective, but again, we only have a window into what that person's thinking. Everyone else has to express their emotions or their thoughts to the viewpoint character. Now there's another uncommon but not unheard of viewpoint, and this is called third person omniscient, and it is where the narrator gets a view into everyone's thoughts and everyone's feelings. So the narrator plays kind of a godlike role in that they're describing what's going on in the entire story and what everyone's motivations are, why everyone in the story does what they do. And this can be an interesting storytelling technique. It kind of limits the writer, though, because the writer can no longer rely on people to be kind of points of conflict. For example, I may have a story in which, if I'm using like a third person limited, in which Sally is friends with John, and then towards the middle of the story, I reveal that John is going to betray Sally, and he does something, and it shocks the reader. So this is a point of conflict. The reader's not expecting it, because they don't know what's going on in John's head. They only know what's going on in Sally's head, and Sally thinks John likes her. If we use the third-person omniscient perspective, you know from the beginning that John is going to betray Sally, because you can see into John's head as well as Sally's head. The narrator's telling you what they're thinking and feeling. And so you don't get that element of surprise. You can't use John as a source of conflict that way. You have to invent some other way to introduce conflict that is interesting, or that would take the reader by surprise. But for the most part, writers in fiction, especially popular fiction, will choose third or first person limited for their viewpoints. My particular story was third person limited, and I only had one viewpoint character. So throughout the whole story, you're only ever seeing everything through one person's eyes, whereas popular authors like George R.R. Martin, in Game of Thrones, he has 270,000 viewpoint characters. Everyone's a viewpoint character at some point, right? So you can do that, but it's very complicated. And the interesting thing about doing that is that if two people are viewpoint characters in different chapters, they can both see the other person, and you know what the other person's thinking based on their particular viewpoint chapters. But when that viewpoint changes, you have to represent the other viewpoint character as that black box. So you can play around with this a little bit and come up with some really creative ways to introduce some character conflict and to do some really interesting things that way. But most stories are third-person limited. So how does this relate to software? Oh, wait a second. Oh, so I kind of already covered this stuff in the previous slide. So there's nothing new here. But how does this point actually relate to software? So at this point, I'm going to ask you to kind of take to make a mental stretch with me, because I'm going to apply this principle to software in a way that's, it's going to be creative. Let's just put it that way. So we're dealing with a system. Maybe it's an object-oriented system. Maybe it's a functional system. Whatever. We're going to have whatever's our system is composed of, objects or functions. We're going to have some of those that are considered viewpoint or domain objects or functions. In an object-oriented system, we might refer to these as aggregate roots, as the domain-driven design people do. And these are simply things in the system which represent the biggest concerns in the problem being solved. So if you are writing an order processing system, you're mostly concerned with maybe an order object, the integrity of an order object, or a customer object, or a shopping cart. All the other objects in the system are kind of just support objects for those big things. So the big things, those are the viewpoint objects. And those viewpoint objects drive the application. In an object-oriented system, or even a functional system where you have modules, you're going to have some objects, or some things that are considered private, and some things that are considered public. You have the concept of visibility. So in a functional system, for example, you may have functions that are encapsulated within a module that only other functions in that module can actually see. In an object-oriented system, you have objects, maybe they're encapsulated in a package or an assembly, and only certain other objects can see them. On a more granular level in an OO system, an object will have behavior and state, and it chooses to reveal certain behavior and certain state to outside objects, and it chooses to hide other behavior and other state. So an object, it should really only see other objects from its perspective. It should not know what other objects are doing internally. So if we apply the kind of the third-person limited perspective to objects, an object only knows what's going on in another object through that other object's API, through what the other object reveals about itself. So an object can actually keep things secret that it doesn't want other objects to know. And this is typically some kind of specialized implementation, right? The interface of an object is how it represents itself to its public consumers. What it does behind the scenes is actually a specialized implementation. And this makes object-oriented programming especially powerful. An object's inner state is known only to itself, but it is visible to the programmer. So the programmer acts as kind of that narrator person. And obviously in a full system, the programmer has an omniscient viewpoint. As he's writing all the objects, he can see into everything that's going on. but the objects themselves can only see other objects through their public APIs. So again, viewpoint is kind of a stretch, but I think it kind of applies. So the next thing I learned is you want to show readers what's going on. You don't want to tell them. And I love this quote by Brandon Sanderson. Brandon Sanderson's an author who teaches at BYU, creative writing. And he says, don't tell us that Bruce hates puppies. Show us Bruce hating puppies. So if I am writing a story and I say Bruce walked into the room and he saw the puppy on the floor and Bruce got angry because Bruce hated puppies. Well, you know, you kind of understand what Bruce is going through. I've told you that. But if I say Bruce walked into the room and he kicked Rufus on, on his butt, and Rufus is the dog, well, then you know, because he kicked him, that he really doesn't like puppies. Not that, we would ever condone Bruce hating puppies, but Bruce is going to be the villain, and so we have to show you that Bruce is really a bad guy. So in software, your objects, modules, and functions, they shouldn't tell us what they're doing. They should show us through a concise and descriptive API. So for example, if we have this some JavaScript code like this, where we have this order object, and we're going to add some things to this object, some line items. So we have the first one, has an ID of 1, a price of 10. The second one, ID of 2, price of 20. And then we iterate over all of these items and increment the total property of the order based on their price. So we accumulate the price. A developer is manipulating items and total directly in this example on the order object. Or external code is manipulating these properties on order directly. The logic for actually accumulating the total price of an order is contained outside of the object. But we could take this and we could turn it into this, where an order now has an add item method, and it has a total method, and it has some state items in total which are considered private, or they're not exposed to other objects. So if another object is a viewpoint object and it's looking at this one, it doesn't see underscore items and underscore total. Now obviously in JavaScript it does see those, but the convention is that the underscore represents things that some calling or external client code should never manipulate. And in this example, we invoke the add item method to actually add a line item to the order. And when we want to get the total, we ask the object by invoking its total function, and it then gives us a total value back. And each time we add an item, the order object does an internal calculation and basically increments its total value based on the new item's price. So in this view, the object controls access to its state, and the logic is contained within the object, not outside of it. This also is a point of maintainability, right? If we want to reuse the logic for calculating the total for this object, we have it in one place, on the order object itself. If we are actually adding items in many places in our system, we don't have to copy and paste the logic from this previous slide. We don't have to actually copy and paste the for each logic here in those places in our system, because it's already part of the order object itself. The next thing I learned was don't let style ruin your story. So style is how a writer writes, their unique fingerprints on a story. If you read an author long enough, you begin to pick up kind of a stylistic sense of how they write. And you can even get to the point where if you read something by them and you don't know that it's by them, because of their phraseology or the way they use certain words, or the way that they tend to unfold a story, you know it's that author. All authors have their own kind of style. So style should embellish the facts of the story. The plot, the characters, the setting. It shouldn't get in the way. Sometimes authors can get a little too wordy. Sometimes they have favorite phraseologies that they like to use, and they tend to overuse those things, and that kind of excessive style starts to detract from the story. Remember, the primary focus of style, or of prose in general, is communication. We want to strive for that Orwellian theory of prose, where our words are simply a window through which we see the story. Likewise, in software developers have styles. If I jump into some code by someone that I've worked with, a lot of times I can pick up on things that they tend to use a lot. And I have the same tendencies. For example, I like to use object.create in JavaScript to set up prototype chains. Someone else might like to use constructor functions to set up their prototype chains. But when people look at my code, they kind of know, oh, well, Nick wrote this function, or Nick wrote this module because this is his style. So your code style, again, like writing, they should embellish the facts of the program. Overuse style can prevent other developers from comprehending your code. If you do particular things a lot, and other developers aren't necessarily used to that, it can trip them up. Another thing I like to do is I like to make use of while loops, sometimes in place of for loops, because I think it's a little bit cleaner. But if other developers are used to seeing for loops in a certain type of flow, it might trip them up. Why is Nick using a while loop here? It doesn't quite make sense. You can take that opportunity if you think your stylistic proclivities have merit. You can take that opportunity to explain them. But the point is that if you're overusing them, you can actually trip up people trying to maintain your code, and it might not be worth it. So the primary focus of code style is communication. The people who maintain your code, the people who have to make changes, add features, might not be you, or it might be you in 6 months. But you want your code to be clear so that it's not going to detract from the task at hand. The next thing I learned is a writer needs to focus on writing, not on tools. So one mantra that we like to have during NaNoWriMo is you want to produce words, and you want to produce lots of them. That is the task, to produce words, to write. Everything else supports that one task, because ultimately at the end you're judged on, did you reach the 50,000 word mark or did you not? You don't want to let fancy tools distract you. So there are a lot of tools that are designed to help writers write their material. There are a lot of really neat software packages that some are free, some are you have to pay for, but they really focus on the domain task of writing particular kinds of books, whether it's fiction or nonfiction or whatever. So lots of these tools, mind mapping tools, diagramming tools, plot outlining tools, timeline tools, tons and tons and tons of tools. But you don't want to let those fancy tools distract you. You want to instead, you want to pick a tool and you want to master it, and you want to make it kind of your go-to for writing. And a lot of times you want a tool that's just minimal, right? That lets you write and doesn't throw a bunch of shiny things in your way to distract you. So in software development, we want to do the same thing, except for we want to produce code, and we want to produce lots of it. Hopefully not lots of bad code, but hopefully lots of code in that we're doing a lot of different projects and we're being productive with our code. Whether that's on open source projects or client projects or your own personal side projects, you want to be producing and writing good code. So don't get tangled up in fancy tools, text editors, IDEs, the latest frameworks, whatever the latest shiny or silver bullet is. Don't let the text editor wars get in your way of actually being productive. You want to pick tool, you want to master it, and you want to write lots and lots of good code. The gains that you get from mastering a particular tool are going to far exceed the gains that you get from trying to juggle a lot of different tools and trying to figure out how they all compare. You will just be much more productive mastering a single tool or a suite of tools. So this is a program called Scrivener, and this is what I used during NaNoWriMo to write my 50,000 word book. And you can see there's kind of a lot going on here. Scrivener has a lot to offer authors in terms of how to construct their manuscripts. And to be honest, Scrivener as a piece of software from a software developer's perspective is one of my favorite pieces of software of all time because it really, the guy who created it really understands what a writer needs to be productive, and every piece of functionality in Scrivener is geared towards making that happen. It's just well constructed, everything works like it's supposed to, everything is intuitive, and it's very, very powerful, it has a lot of powerful features. But if you don't want to use those features, you can turn it into, you can use composition mode, which basically removes everything from the screen except for your blinking cursor and fades everything behind you to black so that it's just you, a black screen, and your words. And that's often a great way to get into the flow of writing and turn off all the distractions behind you. And you can see this kind of looks like an IDE actually, not unlike the tools that we use in software development. So I want to talk a little bit about magic. So my story for NaNoWriMo was a fantasy story, so I obviously had magic in my story. I'm a big fan of fantasy and science fiction. Those tend to be my go-to fiction genres. By the way, science fiction has magic in it as well. I heard someone once describe Star Wars as space wizards with laser swords. So, magic is simply the things that we just assert about our universe that we don't explain. They just happen, and they tend to be fantastical. So, but magic is interesting from a writing perspective. Magic, when you introduce magic into your story, you want to set up some rules for your magic. For example, it's no fun if I write a story where the protagonist who can use magic to just solve any problem, right? He or she is a super wizard, and any problem comes up, and voila, everything is solved. One critique of the Lord of the Rings movies when they came out is, why didn't Gandalf just call the eagles to come fly everyone directly to Mordor, right? That would have fixed the entire thing. They wouldn't have had to gone through all the conflict and all the tribulation and all the attacks from the orcs, and they wouldn't have to deal with any of that. They could have just flown straight to Mordor, dropped the ring into the volcano, and been done with the story. Well, that doesn't make for a very interesting story. Who's going to read that? Nobody's going to read that. It's certainly not going to be a great epic story. So we have to have rules on the magic, what a person can and can't do with their magic in a story. The rules on magic systems, they set the stage for reader inference. And what this means is that if you say, for example, say you have a story with a king, and the king has a flaming sword. And with this flaming sword, he can vanquish all his enemies. But the rule is that the flaming sword cannot be used against any enemy who also wields fire, or something like that. So you have this rule. So what happens when, in your story, there's rumors of a dragon that lives over in the next kingdom? Well, all of a sudden the reader is getting some inference that there's going to be conflict coming up. The king is not going to be able to defeat this dragon because obviously dragons breathe fire, and the rule's already been set up that he can't use his flaming sword against a being that also uses fire as a weapon. So they set the stage for reader inference. And you can also set the stage for inference of how magic is going to be used to solve problems as well. They prevent writers from using magic as a deus ex machina, or just simply as a get-out-of-jail-free card for conflict in the story. And you want to, and not only does magic have to have rules, but you want to have your magic systems have a cost to the wielder. So if, for example, you had a story where anytime a person wanted to use magic, maybe everyone in this story can use magic, but anytime a person wants to use magic, they have to cut off one of their fingers. Well, the conflict is obviously you only have 10 fingers, so anytime you run into a problem, you have to make a decision, your character has to make a decision, is it worth one of my fingers? And is it worth having one less opportunity to use magic? Because once all my fingers are gone, I can't use magic anymore. So that's an actual tangible cost to a magic wielder, and it introduces additional conflict in your story. So when you set up rules for your magic system, if you have hard rules and lots of rules, like rules that are explicit, you can't use the flaming sword against enemies that also use fire, then you can use your magic to solve interesting problems. Because the reader knows what the rules are, you can introduce a problem, and then your characters can work within the rules to creatively solve that problem. And the reader feels really satisfied when that happens. If your magic system tends towards no rules, you can have magic as kind of a prop piece where it can invoke a sense of wonder in your reader, where they see magic as more of this awe-inspiring type of thing, but you can't really solve any problems with it because it will tend to feel like a deus ex machina. And this is why Gandalf doesn't use his magic often in Lord of the Rings, because there's not a lot of rules associated with it. We want to feel that Gandalf is very, very powerful, and that somewhere in the background there are rules around his magic, but it's never stated explicitly. So Tolkien uses the magic sparingly and in a few places where he's trying to give us a sense of wonder about Gandalf, not necessarily a sense of fulfillment that the magic was used to solve specific problems. So, and just so you're wondering, this breakdown of magic systems, having hard rules, no rules, solving problems, sense of wonder, this again comes from Brandon Sanderson, who does a tremendous class on creative writing out of BYU. It really helped me understand how this is all set up. So in software, and here I'm going to make another leap, we also have magic. And that magic comes in by way of frameworks, libraries, or systems that do things for us, often without explaining the how or the why. So, for example, you take, let's say Rails would be a particular instance of a type of magic. Rails does a lot of things for a web developer behind the scenes. A developer doesn't necessarily have to understand how all those things work. As long as they abide by the conventions in Rails, they get those things for free. So these bits of magic, these frameworks and libraries and stuff like that, they have rules or particular use cases, limitations, and assumptions in which their magic is effective. And this is important to realize. This is where we get phrases like, for example, the Rails way, or the Angular way, or the Microsoft way. What those things are expressing is that our frameworks, whether they're Rails or Angular or something from Microsoft, they give you things for free. They give you the magic. But in order to use the magic, you have to work within the rules that the framework sets up, within its conventions. And if you move outside of those conventions, things can go horribly, horribly wrong. So you want to make sure that you understand what those rules are. Magic and software, if we're going to use magic, or even if we're going to create things that are magic for other people to use, they need to be consistent. A developer should be able to infer logically consistent consequences from the use of magic. So whatever the rules are, they should be well explained. And you should be able to look at those rules and say, well, if I need to do X, and the framework is telling me that Y is the use case that it handles, it might not be wise for me to choose this specific piece of magic to accomplish something. The rules for software magic, they prevent this magic from being used as a silver bullet for any problem. So you can't just go into a meeting, for example, and claim that Rails or Angular or whatever solves every problem. You just can't do that. They don't solve every problem, and they're not designed to solve every problem. They solve a specific subset of use cases for which the magic rules apply. Magic also in software has a cost to the developer, namely the inability to easily debug things. Sometimes when one of these frameworks or libraries does something behind the scenes, it becomes very difficult to have a view into the traceability when something goes wrong. You don't know exactly maybe where an error was generated. You don't know why an error was generated. And so you spend a lot of time on Google or Stack Overflow trying to figure out why something is going wrong based on a use case that you just didn't anticipate having a problem with. So this is a cost to the developer. It's something that you're giving up control in order to get some feature or something done for you. So Brandon Sanderson has what he calls his first law of magic in writing. And he says, your ability as an author to solve problems with your magic is directly proportional to how well your reader understands your magic system. And what this means is that the reader will feel a sense of satisfaction for when you solve problems with magic if they understand the rules of the magic system really, really well. So I kind of took this to an extreme, and I was having a conversation in our company chat one day, and we were talking about frameworks. And I said, frameworks are kind of optimization. They simplify a problem context by assuming that most problems within that context are similar. I think frameworks are valuable for A, simple projects in which you can be certain that the framework is more than adequate, and B, complex projects in which the developer already has a working knowledge and understands the problem space enough to know immediately where the framework will fail and how its failures can be mitigated. To paraphrase Brandon Sanderson's first law of magic, a framework's ability to solve conflicts with magic is directly proportional to how well the developer understands said magic. So the idea here is that if you introduce a framework or a library or a system and you don't know how it works and you don't know what the use cases for which it is valid and for which it is invalid are, then you are necessarily limiting yourself in the ways that you can solve problems with that framework, and you're probably going to run into some serious options. So not to say that magic is bad. Magic is good and can be very helpful in software, but we want to make sure that we understand all the things that go with it, and the costs associated with it, and the rules associated with it, and then we can be most productive. The next thing I learned is a word called BICHAC, and this means button chair, hands on keyboard, or hands at keyboard. Shouldn't be hands at keyboard. Basically, writing is hard and it takes time. And in order to be a productive writer, you have to be disciplined, and you have to sit down, and you have to write words, and you have to do a lot of thinking, and you need to make your story progress. It's not going to get written for you. It's very much a discipline-oriented practice. When writers have writer's block and they say, oh, I just can't write anymore, I don't feel the inspiration or whatever, there is a cure for that, and it's called writing. Putting your button in the chair and pounding out words. Even if you don't feel like it, even if you're not inspired, even if you think it's the most horrible dredge that you've ever written, that is the cure for writer's block. The activity of writing is itself a creative stimulus. It will actually fuel your creativity the more you do it. And so to break out of that kind of writer's block, that inability to generate ideas, you need to sit down and just start writing. Even if it's bad, it will stimulate that part of your brain that comes up with the good ideas and that makes you a creative being. Getting started is the hardest part, but once you do, your momentum carries you. Writing software is the same way. It's hard, it takes time. When you're stuck on a problem, sometimes coding something else is the cure for coder's block. So if you're trying, and this has happened to me, where I'll be working on a problem in a client project, and I'm just not understanding the solution, I'm just not feeling inspired. I'll set it aside for a half hour, an hour, and I'll go work on an open source project that I'm passionate about, and then come back to the problem that I was stuck on. And a lot of times, just having that shift in context and sitting down and writing other code is enough to get me over the hump and give me the momentum to keep going. This is a chart that shows my progress over the month of November when I was writing, and you can see that it's going from 0 words on day 1 to 50,000 words. Actually, I was about 5,100 or 51,000 words, sorry, by the end. But you can see the point is that the diagonal line, each bar raises either almost to the diagonal line or slightly exceeds it. And the point was that I kept up my pace and I kept up the discipline enough to get the 50,000 words done by the end of the month. So you need to be consistent, and you need to devote time to actually thoroughly learning your craft and writing code, putting your butt in the chair and actually doing it in order to meet the goals that you want to meet. I love this image. I found this when I was participating in NaNoWriMo, and it's an artist, Aphex Angel, and it says, "Writer's block, please excuse me while I try to beat the shit out of this." And the idea is that, writer's block is not going to go away just because you want it to go away. You have to do something to make it go away. And a lot of times it's just pounding out more words. Here's another little phrase that I hear often at NaNoWriMo. You have 1,000,000 words of crap in you before you get to something worthwhile. And the idea is that you have to practice. Practice makes perfect. Malcolm Gladwell in Outliers, his book Outliers, talks about the principle where in order to master something, you have to have 10,000 hours of practice under your belt doing that thing. And this is kind of the same principle, is that don't expect, as a writer, you don't expect to produce something good right off the bat. It's going to be rough. It's going to be, probably be horrible or whatever. But that's okay. That's not the point. The point is to get the practice in and to get the discipline, get yourself disciplined, doing revisions, understanding plot and character, and learning through that experience. And once you get to 1,000,000 words, you've accumulated so much learning that you're kind of on autopilot at that point, and all of that learning experience is coming out in quality material. I've listened to interviews with well-known writers who produce excellent material, and they all say the same thing. Their first drafts are horrible. They hate their first drafts. The book that you pull off the shelf or that you download on your Kindle or your iPad, that book has gone through tons of revisions. That's not what they wrote the first time. Keeping that in mind when we see our own code, or we see, if you're writing, you see your own prose, the first time through is going to be rough. Don't sweat it. Just keep writing, keep coding, and turn it into something worthwhile. Another thing I learned about is writing groups. A writer can benefit from the experience and from the opinions and ideas of other writers. So oftentimes writers will form writers groups in which they will submit material to the group to read, maybe a chapter of a book they're writing. And the group will read their material ahead of time, they will meet, and then they will critique the material. And this, everyone in the group participates in this process. So there are two parts to this. One is if your work is being critiqued, and the other is if you are critiquing someone else's work. So in the case where your work is being critiqued, there's a hard rule that says you cannot speak except to ask questions of the people who are talking to you, who are critiquing your work. Your goal is to sit there as a writer and listen to what they're saying. If your piece, if your chapter, or whatever, if it can't defend itself, it is broken. And what that means is that you're trying to convey something to your readers. And if the people in the writing group are not understanding what you're trying to convey, if they are telling you things that are way off about your chapter, they don't understand the characters, they don't know where the plot's going, whatever. If your piece isn't actually conveying those ideas, that's when you know it can't defend itself, so it's broken. When I say broken, I don't mean that your prose is necessarily bad or that maybe certain parts of it aren't good. I'm saying it is not doing what you want it to do. So it is broken in that sense. It's not meeting your goals as a writer. So obviously during this process, you want to take lots of notes because this is going to be your the feedback that you take to try and go back and rework this piece. So in software, we do something similar. We don't have writing groups, but we do have code reviews. So when you're in a code review and your coworkers are critiquing your code, we can apply some of these same principles. You want to listen and ask questions. You don't want to try to defend your code. It's not personal. When someone looks at your code and says, I don't understand why you did this, or maybe this would be a better approach, you don't defend your code. It's not personal. They're simply saying that the way you're trying to express the solution of the problem is not clear. If your code can't defend itself, so it is broken at that point. The people who are going to have to maintain it or who are going to have to add features to it, they don't understand it, so it's broken. And you want to take lots of notes during your code review. Don't take it personally. They're not out there to personally attack you, but they're there to help you understand how to make your code better. When you are the one doing the critiquing of someone else's work in a writing group, you don't attack the writer. The goal is not to tell people that they're bad writers or that they shouldn't be writing. Your goal is to identify problems with the work, problems that are keeping it from being clear or expressing what the author wants it to express. You want to be descriptive about these problems, not prescriptive. You want to tell the author what your impressions are, not how you think the piece could be better. So don't say, this character should do this, instead of what they are doing. Say, I know that you want this character to end up over here, but I don't understand how they're getting from this point to this other point. It's not clear to me. These things are in the way, or these things seem inconsistent. Again, you're not telling them how to fix something per se. You're simply describing that there's a problem and all the hangups that you have with that problem. You want to also tell the writer what does work in the piece. So give positive feedback if they do something particularly well, or if there's a part of the chapter or whatever that you particularly like, point that out. Knowing what we do right is oftentimes the salve on the burn of knowing what we did wrong. And finally, focus on bigger problems that cause issue with the work as a whole. Don't get, in a writing group, you don't want to get caught up in small issues of maybe grammar or spelling, unless it's just completely atrocious. Or small little things like this sentence doesn't flow well or whatever. You're looking for plot problems, character problems, ambiguity in communication, those types of things. In code reviews, if you're critiquing another person's work, you don't attack them. You don't attack programmers. You're there to identify problems with the work, not with the person writing the code. Tell them how their code strikes you, not necessarily how you would fix the problem. This can kind of be a big one. I know I'm guilty of being prescriptive with people when doing code reviews. I think it's okay to suggest alternative paths to things, especially if you can say, if I wrote this, here's how I would express this clearly, but leave it up to them and how they want to implement a solution to fix it. But again, express how their code is striking you. Are they solving a particular problem, or do you not understand the solution that they're trying to implement? Tell them what does work in their code, the things that you do like, the things that you think are clever. Developers, we want to be clever, and we want to know that our ability to be creative and solve problems is strong. And so identify those things to help someone feel that they are actually in a right place, on the right track. There's just some issues with some of the problems they're trying to solve. And focus on bigger problems that are going to cause issues with the program as a whole. Don't necessarily focus on minute things. Don't worry too much about tabs versus spaces, or don't worry too much about putting all your variable declarations at the top of a function in JavaScript. Those types of things can be hair splitting. But we want to focus on bigger problems that are going to affect the entire program. So finally, this image was the background wallpaper for my computer during NaNoWriMo, and it's a quote I'm going to leave you with at the end of this presentation here. Benjamin Franklin said, "If you would not be forgotten as soon as you are dead, either write things worth reading or do things worth writing." And in software, I think we can apply this and say, write software that's worth using. Like, the whole goal of being a software developer is to solve a problem, ultimately for a reason in the real world. We want to help a user do something, or we want to automate some process to make someone's life easier. So we want to write software that's worth using, that has a strong utility value. And sometimes it's easy as developers to get lost in the details and the art of software in and of itself, and forget that software is just a tool to accomplish things in the real world. And so, we want to focus on writing software that people are actually going to use as kind of a legacy of our careers as developers. So thank you. I hope you enjoyed the presentation. I hope you didn't think my ideas were too much of a stretch. If you want to reach out to me on Twitter, on GitHub, I would appreciate any feedback on this content. Thank you.